My name is Jeremy Bruton. I'm a junior at Lawrence University studying government and economics, and my presentation will be on the defensive shift in Major League Baseball. So, a quick background, what is a shift? A shift is essentially the idea that Major League teams are starting to place their defenders in different positions. So, on the right here, this is a shift, and on the left, this is the standard normal positions for baseball games. And so on the right, you have a left-handed batter. And the idea is that left-handed batters oftentimes hit the ball more frequently to the right side of the field rather than to the left side of the field. So for defenses, they will place their players in positions that are more frequently to be hit to. So quick motivation for this study. Essentially, the idea is that in Major League Baseball, there's been a bit of a pushback over the last couple of years towards the shift, under the assumption that it is ruining offensive output. And so I wanted to answer, is that true? Is the shift really adverse to offenses, and is it really ruining offensive output? So there is some theory behind why this could be true, but there's also some theory as to why maybe the shift is beneficial for offenses. So why could the shift possibly be beneficial for offenses? Well, the idea is this. If you place all your position players on the right side of the field for a left-handed batter, it leaves this left side of the field wide open, and it essentially cuts down the strike zone that the pitcher can pitch to. So a pitcher cannot throw as many pitches in zones 1, 4, and 7 as the hitter could then take that to the opposite way. So to answer the question, is the shift really ruining offensive output? I looked at all batted balls from the 2019 MLB season, excluding sacrifice bunts. I used StatCast data from Baseball Savant, which is a major baseball database. A batted ball is simply any time a hitter will put the ball into play. That data is then split into 6 different categories of contact quality proportions. So each time a hitter hits the ball, it will be split into one of these 6 in this table below types of contact quality. And then I break these into 2 different groups of proportions. So batted balls when a shift is present and batted balls when a shift is not present. So my research questions were, first, does this defensive shift employed by an opposing team affect an MLB team's batted ball quality? The null hypothesis is that there is no difference in contact quality proportions when a team faces a certain type of defensive alignment, and the alternative hypothesis is that there is a difference in contact quality proportions when a team faces a certain defensive alignment. Then if we reject the null hypothesis, we can move to question 2, which is really the question of interest, is how does this difference in batted ball quality affect offensive performance? So first, is there a change in batted ball quality? To answer this question, I use a ChiSquared test to evaluate statistical significance between contact quality proportions relative to defensive alignment. So when I do this, I get a chi-squared test statistic of 262.74 and a correspondingly small p-value of almost 0. Therefore, we can reject the null hypothesis that there is a difference in contact quality proportions relative to defensive alignment. However, we have a large sample size of 125,000, so it's not surprising that we receive a small p-value of almost 0. Therefore, to assess the baseball significance of this study, I perform another chi-squared test to test for differences in the proportion of barrels relative to defensive alignment. So I specifically look at this relationship here of just barrels. So as you can see, in the 2019 season at least, when facing a shift, barrels happened at 1.6 percentage points higher than against a non-shift. So I again use a chi-squared test to test for differences in the proportion of barrels relative to defensive alignment. And I again get a large chi-squared test statistic of 113.26 and a p-value of almost 0. So the question now becomes, is this increase in barrels when facing the shift of any practical baseball significance? So I asked the question, do increased barrels actually improve offensive performance? To measure this, I use 2 types of offensive metrics. I use batting average on balls in play plus slugging percentage, and that is used to measure offensive performance. So a high babip plus slugging equals better offensive outcome. So on the right, I have a stacked area chart, which shows the quality of offensive performance produced by each type of batted ball. So the colors are the different types of contact quality. And as you can see here, the further to the right you are on the x-axis, on the babip plus slugging axis, the higher offensive output you have. So the barrels do result in the highest offensive output quite significantly, as shown in the reddish pink stacked area. And why would this be important? Well, if we combine our research from the last two slides, it suggests that first, there is a difference in batted ball quality when facing different types of defensive alignments. Particularly, there is an increase in barrels when facing a defensive shift. Our research also suggests that barrels do indeed result in the greatest offensive output. Therefore, if a shift results in opposing batters barreling more balls, and barrels therefore result in the greatest offensive output, this research could suggest that MLB teams are shifting too much. So the idea of the shift is really to minimize offensive output from a defensive standpoint. And if these shifts are allowing a hitter to understand the zone better in which a pitcher will throw, and they therefore are barreling more balls, which result in the highest offensive output, it could suggest that these teams are not considering some of the adverse effects of the shift. However, this study should really just be looked at as a first step or an introductory to understanding the true effects of the shift. And some of the limitations of this study include, first, the shift is a relatively new concept. It's only been around in Major League Baseball for about 5 to 7 years. And it's only been around for about 5 to 7 years, and it's really taken off in the last 2 to 3 years specifically. Second, our study does not consider many important factors that go into understanding any given matchup outcome. So first, for example, batter and pitcher handedness, there are right-handed hitters and left-handed hitters, and there are right-handed pitchers and left-handed pitchers. And right-handed hitters often perform much differently against right-handed pitchers and left-handed pitchers. So our study does not consider that important factor. Second, the count. So batted ball quality is quite different from different counts. So a 3-1 count oftentimes has an aggregate batted ball quality much different than a 0-2 count. Third, type of pitch. So this could be different for fastballs versus off-speed pitches or curveballs and sliders. That can all greatly impact any type of batted ball quality. So therefore, the next steps to truly isolate the causal effect of a shift. First, it would be important to repeat this study over different time periods. So I only looked at the 2019 MLB season. This would be important to look at maybe the 2018 and 2017, and even to carry this over and say, did this trend continue in the 2020 season? Second, it would be very important to break the data into more specific subgroups. So I mentioned some of those specific subgroups earlier. Other subgroups that you could break the data down into is really good hitters and maybe average hitters, and significantly better pitchers and average pitchers to understand that maybe is this shift happening for a specific subgroup of the whole baseball population, or is this a trend that is general across the entirety of baseball? So that is my presentation. If you have any questions, I would be happy to take them. Thank you all for listening, and I am excited to listen to the rest of the conference.